This presentation is part of the TI in Focus AP Calculus video series. In this video, I'll discuss the scoring guidelines for the 2022 AP Calculus exam, free response question AB1 BC1. My name is Steve Kokoska. I am a professor emeritus at Bloomsburg University in Pennsylvania, and I am a former AP Calculus chief reader. Here is an outline of the information presented in this video. I'll start by reviewing the free response question, the point distribution, and then the scoring guidelines used at the AP Calculus reading in Kansas City and for readers off-site. I will present more detailed solutions where appropriate. And then I will consider more interpretations of the scoring guidelines and how these guidelines were applied in certain situations. I will also consider some common student errors where it is relevant. And finally, I will include a few extra problems for you to consider, all associated with the information in this question. The format for the AP Calculus scoring guidelines has changed in the last 2 to 3 years. So, just a few general notes before we begin. The model solution given in these guidelines is presented using standard mathematical notation. In general, other solutions using correct mathematics are eligible for all points. And remember that a final numerical answer does not need to be simplified. If a response includes an error in simplification, then the response will most likely lose a point. Decimal approximation answers must be given to 3 digits to the right of the decimal, rounded or truncated. Within each question, at most 1 point is lost for inappropriate rounding. Well, this question is calculator active, and it involved vehicles arriving at a toll plaza. We are given the rate at which vehicles arrive at the toll plaza, and we know that no vehicles are waiting in line at 5 a.m. or at t equals 0. In Part A, we need to find an integral expression that, if evaluated, gives the total number of vehicles that arrive at the toll plaza from 6 a.m. to 10 a.m. Part A was worth 1 point. There is no calculation necessary here. The student simply needs to write either this or this integral expression. A of t is a rate, and this integral expression represents an accumulation of the number of vehicles that arrive between 6 a.m. and 10 a.m. That is, between t equal 1 and t equal 5. Note that I recommend that students use the first expression with the named function a of t. If the student uses only the actual expression for a of t and makes a copy error, they will not earn the point. Here are the scoring notes associated with Part A. First, the response must be a definite integral with the correct lower and upper limits in order to earn this point. So this response with an incorrect lower limit does not earn the point. And this response, which is an indefinite integral, does not earn the point. As you might expect, a of t is positive over the interval 1 to 5, in fact, over the interval 0 to 5. It represents the number of cars arriving at the toll plaza. So the absolute value of a of t is equal to a of t. Therefore, we will accept either of these definite integrals. We are, in general, where there is no ambiguity, forgiving of responses that do not include a differential or mix the variables. So these two expressions would each be eligible to earn the point. That is, as written, they each earn the point, but the response may go on to include a copy error, in which case they would not earn the point. So, a response with a copy error in the expression for a of t will earn the point only in the presence of the correct definite integral with a of t as the integrand. So this response earns 1 point. But this response alone, with an error in the constant, does not earn the point. Here are some common errors in this part and how each response was scored. Many responses conveyed the correct conceptual idea in Part A. However, some responses did not use proper notation. Here is an example. This response did not earn the point. Some responses included a constant in various locations in the expression involving an integral. Neither of these expressions earned the point. Note that in the second expression, the integrand is ambiguous. It's not really an issue here because there shouldn't be an additional constant anyway. But this is a common error in other similar problems. And some responses included a summation symbol. This response did not earn the point. And finally, here are two more common responses that did not earn the point. In the first, the response uses a prime of t instead of a of t. And in the second, the bounds on the definite integral are incorrect. Now, we think we understand where they came from, 6 a.m. to 10 a.m., but they are wrong. However, students who continue to make this same mistake in later parts of this problem could earn points, as long as the complexity of the problem remained the same. In Part B, we need to find the average value of the rate at which vehicles arrive at the toll plaza from 6 a.m. to 10 a.m. That is, from t equal 1 to t equal 5. Part B is worth 2 points. The first point is for using the average value formula, and the second point is for the answer. The solution here is pretty straightforward, although we do need to use technology. The average value is 1 divided by 5 minus 1 times the definite integral from 1 to 5 of a of t dt. And then we need to use technology to find this value. I will be using the TI-Nspire CAS calculator. I first defined the function a, and then I simply evaluated the expression. The average value is 375.536 truncated, or 375.537 rounded. Here are the scoring notes associated with Part B. The use of the average value formula can be presented in a single step, over multiple steps, or even implied. Here's an example response that earns both points. The use of the average value formula, the definite integral multiplied by 1/4, is implied. Note, however, that the response cannot use incorrect notation to connect these two values. That is, 1502.148 cannot be set equal to 375.537 in some sort of train of thought process. And this is demonstrated in the next scoring note. Here the response has connected two values that are not equal with an equal sign. This is an example of incorrect notation, and it earns one of the 2 points. The final numerical answer must be presented correct to 3 decimal places. So this example in the scoring note, rounded to 376, earns only the first point. And this example, rounded to 2 decimal places, earns only the first point. Now note that if this error is made, the response will not lose any additional points in this problem for decimal presentation errors. Some students, unfortunately, tried to solve this problem with their calculator in degree mode. Now, I don't intend to discuss this issue in great detail. It is enough to say that we have a very fair way to recognize and score these responses. Students can still earn most points for consistent calculus work, as long as the problem has not been simplified by degree mode. And finally, this special case in which the response used 1/5 as the constant out front instead of 1/4 earns one of the 2 points. Here are some common errors in Part B and how each response was scored. Unfortunately, Some responses presented the average rate of change of A instead of the average value of A over the interval 1 to 5. This response did not earn any points in Part B. Some responses used A prime of t in the integrand. This also earned 0 points in Part B. Some responses rounded the average value to an integer. The non-integer or the decimal answer here has real meaning. So rounding the correct average value expression earned the first point, but not the second. And finally, some students started with 1/5 times the definite integral 1 to 5 of a of t dt, or even wrote this expression after writing 1 divided by 5 minus 1 times the integral from 1 to 5 of a of t dt. This arithmetic error lost at least one of the 2 points. Degree mode was an issue in Part B also, but it was scored fairly and consistently. And some students presented 1 divided by 10 minus 6 times the definite integral from 6 to 10 of a of t dt. Now, this did not earn the first point, unless already penalized for this error in bounds in Part A. So it could earn the second point with the correct answer for this expression. In Part C, we need to determine whether the rate at which vehicles arrive at the toll plaza is increasing or decreasing at t equal 1. And we need to provide a reason for the answer. Part C was worth 2 points. The first point is for considering a prime of 1, and the second point is for the answer with a suitable reason. To solve this problem, we need to find a prime of 1. Note that this value was not asked for in the question, so all we really need to report is that the value a prime of 1 is greater than 0. Therefore, the rate at which vehicles arrive at the toll booth plaza is increasing. Here is the technology part of this problem, finding the value of a prime of 1. Here are the scoring notes associated with Part C. Again, the response does not need to present the value of a prime of 1. Here is a succinct, sufficient response that earns both points. A prime of 1 is greater than 0, so the rate at which the vehicles arrive is increasing. If an incorrect value of a prime of 1 is reported, the response earns the first point, well, for considering a prime of 1, but not the second point. Here's an example. Just a prime of 1 equal 150 earns the first point, again, for considering a prime of 1. If there is no explicit reference to t equal 1, the first point can still be earned. If any of these values are presented, or even if the response includes a prime of t equals 148.947, then this earns the first point. To be eligible for the second point, the first point must be earned. And this makes sense. If the response has not considered a prime of 1, then the answer and reason cannot follow. So a score of 0-1 in Part C is not possible. To earn the second point, there must be an explicit reference to t equal 1. And here is the answer if the student is in degree mode. Again, we will treat this fairly and consistently. Here are some common errors in Part C. Some responses simply did not communicate precisely enough in order to earn both points. As indicated in the previous slide, a simple one-sentence response could earn both points here. Some responses did not use Leibniz notation correctly. So if a prime of 1 was not clear, the response did not earn the first point. Some responses included discussions of a prime of t, not a prime of 1. Responses that used and discussed a prime of 6 did not earn either point, unless of course they were already penalized for this error in parts A or B. Some responses used the ambiguous phrase, the derivative, instead of the derivative of A. The derivative is simply not precise enough. Similarly, some responses used the phrase, the rate of A of t, instead of the rate of change of A of t. And finally, some students actually tried symbolic differentiation to find A prime of 1. This is indeed possible, but it's not necessary here. This was a calculator active problem, and students just needed to find the sign of A prime of 1. If the symbolic derivative presented was incorrect, then the response was not eligible for the second point. In Part D, we need to find the maximum number of vehicles in line at the toll plaza in the time interval A less than or equal to t less than or equal to 4. Part D was worth 4 points. The first point was for consideration of n prime of t equals 0. The second point was for finding the values of A and B. And the third and fourth points were for the answer and justification. Especially in this part, remember that the scoring guidelines present a model solution, one way to solve the problem. There may be others, correct solutions that earn full credit. We are given the function n that we need to maximize. Now it looks a little strange because there's an unknown constant a as the lower bound on the definite integral. But let's proceed as usual in an optimization problem. Find the derivative n prime of t using the fundamental theorem of calculus and set this equal to 0. Using technology, I found two values, and I stored them in the variables c and d. Note that I already used a here to identify the function capital A, so that's why I used c and d on my calculator. And just so that I can understand this problem a little bit better, here's a graph of A and the horizontal line y equal 400. Now we know that a line forms when the rate is greater than 400 vehicles per hour. And we can see from this graph that the rate is below 400 once t is greater than 3.598. So this graph almost tells the whole story. The line begins to form at t equal 1.469, and it continues to build until t is equal to 3.598, when the rate falls below 400 vehicles per hour. And therefore, the size of the line will begin to decrease. Now, let's verify all of this with a table of values. So I will use a candidates test to find the absolute maximum value. Using technology, I first defined the function n. Then, on a lists and spreadsheet page, I evaluated n at the three values. Well, the two endpoints and t equal 3.598. Therefore, the maximum number of vehicles in line is 71. Here are the scoring notes for Part D. First, it is not necessary to explicitly write A of t is equal to 400. This statement is implied in the presence of t equal a and or t equal b. So, if a response has t equal 1.469 and t equal 3.597, well, that earns the first 2 points. This response, A of t greater than or equal to 400, when 1.469 is less than or equal to t is less than or equal to 3.598, earns the first 2 points. However, a response with A of t greater than or equal to 400 and only one of the two values, A or B, earns the first point but not the second. And a response of just A of t greater than or equal to 400 does not earn either point. And, as usual, to earn the second point for the values of A and B, these values must be presented correctly, with at least one digit to the right of the decimal up to 3. Remember, the question did not explicitly ask for these values, so there is flexibility in scoring for these values. And these values could appear in a table as limits of integration, or even on a number line. Some reasonable presentation or some reasonable use of these two values. Here are the values we accept as evidence of finding the values for A and B. A response may use the variable x instead of t, and this is still eligible for all 4 points. A response does not have to earn the first point to be eligible for the remaining 3 points. One way for this to happen is if a student presented a graph of A and the horizontal line y equals 400 without ever writing the equation A of t equals 400. To earn the third point, the answer point, the response must present either 71 or the answer to 3 decimal places. Remember that if more than 3 decimal places are presented, we ignore the extra digits. And a correct justification earns the 4th point, even if the 3rd point is not earned due to a decimal presentation error. In the model solution, the justification is the table of values. If the response includes a table of values or the candidate's test as justification, then all 3 values, n of a, n of b, and n of 4, must be presented, and the values presented must be correct, up to 3 decimal places. Here, correctly rounded integer values are acceptable. Remember, the question asks for the nearest whole number. Here is an alternate solution. I think many students solved the problem this way. They had some good insight after examining the graphs of A and y equals 400. And finally, in degree mode, this response is only eligible for the first point because in degree mode, A of t is less than 400. Here are some common errors in Part D. Some responses presented an incomplete table of values without specifically ruling out candidates, and some responses provided justification only for a local maximum. Another common error was to omit the value for n of a in a table of values. And again, presentation of a graph of A and the line y equals 400 provided some good insight into the problem, but it did not alone earn the first point. Some responses relied on a sign chart solely for justification. But remember that a sign chart is not sufficient justification. The response must interpret the chart. And finally, here's a typical statement that indicates a local argument and therefore insufficient justification. Here are a few additional questions to consider that use the information presented in this question. First, find the minimum rate at which vehicles arrive at the toll plaza. Next, let's suppose we also know the rate at which vehicles leave the toll plaza, given by the function L. You might first think about how this changes the very nature of this question. And then find the number of cars in the line at 8 a.m. Find the time at which the number of cars in line begins to decrease. And if the number of cars in line reaches 500, then another toll booth opens. Find the first time that this occurs. And finally, find the maximum number of cars in line for 0 less than or equal to t less than or equal to 5. During the actual AP Calculus reading, readers review the scoring guidelines, discuss this document with a table leader, and then learn more about scoring the problem by working through training feedback samples. I hope this summary video captures the important aspects of this process and gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.